I created this template to help kids model operations with fractions that of course only have quarters, halves, eighths, and sixteenths, because they're all going to be modeled on the ruler using line segments. They can compare fractions, they can do mixed numbers, many different things you can do on this particular template. You'll also notice when you look at the template, what I did is I created a ruler that is about twice the size of an actual ruler, maybe even a little bit bigger. This helps the kids make that adjustment between reading a ruler that is obviously authentic, that's a foot long. It just helps them read it a little clearer here, and then they can move into the ruler later on. But let's see if we can just do some examples here. What I'd like to do is I want to take a look at comparisons. So we can compare 3/4 and I don't know, let's say 5/16. So if we compare those two fractions, what we want to do is use two of the ruler bars here and just grab one of the segments, and we're going to move that over, and we'll start at the 0, and we want to go 1/4, 1/4, 2/4, and then 3/4. So that's 3/4. Do the other one in a different color on another ruler, and you want to go 5/16. So this is 4/16, 5/16. When they actually look at the two models, they can easily put in the inequality sign and make a true number sentence. 3/4 is greater than 5/16. Great way to get them to compare fractions and then make some conclusions later on after they do some practice. Remember, every kid in the class is making that model either as you were modeling it on the smartboard, or as you just write it down. They do it, and then you can have them come up and draw it, or you can then draw it to substantiate what they did after they hold up their communicators. So let's try a problem beyond comparisons. Suppose we now want to add them together, and basically when we want to make a model of addition, we can write down a problem of, let's say, I don't know, let's say we want to add 5/8 to 11/16. So if that was our problem, we're going to use one ruler, and let's grab the blue segment, and we'll make that one be 5/8. So we're going to go 1/8, 2/8, 3/8, 4/8, and 5/8. And now you can bring that down and be a little closer if you want to make the 5/8. But the point is, they can see the 5/8. Draw another color, and you can connect that to the one you have, and we want to make this one 11/16. So you're at 1, 2, 3, 4, 5, 6/16, 7, 8, 9, 10, 11/16. So now you have your model, and you can bring that down and match it, or just leave it where it is, whatever you want to do. And you can actually label them if you want to make it a little clearer for the kids. You got to label that to be 5/8, and then we can add that to 11/16. And now what's the answer? Well, there's two ways to look at this. Some kids are going to see right away that they can read that as a 1, and then you have your 5/16. So they can write the answer as 1 and 5/16. Other kids won't do that. They'll see that the 5/8 becomes 10/16, and then they'll see that they have the other 11/16, which is 21/16. Or they can read this as 16/16 for the 1, and then the 5/16 over here, and they would see that that's the 21, or 1 and 5/16. So you could have them write that as 21/16. And then from the model here, they could see that that really is 16/16 plus 5/16, which of course is going to give them 1 and, let's narrow down here, and it's 1 and 5/16. Okay, so that's a model for an addition problem. If we erase all this and go to our next problem, what we can do now is we can take our segments off and start all over again. This time I'm going to do a subtraction problem. Suppose I were to ask the kids to take 1 3/4, and I want to subtract from 1 3/4. I want to model subtracting 7/8. Okay, So again, grab any color segment that you want, and we're going to clone it, and we go to our ruler, and we're going to measure out 1 1/4, 2 quarters, 3 quarters. So that's cool. Now what we want to do is take 7/8. So we'll take another line that shows a pretty good contrast. Now instead of adding it on the end, we know we're going to subtract it. So we're going to start with our model, and we're going to subtract 7/8. So down to here is 6/8, and one more is 7/8. So now that gives me my segment that I'm going to remove. Well, there's two ways to look at it. The kid can either read this, or they can draw in another segment, and they can move that over, and then they can read that segment to be 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, and of course the answer is 7/8. So we can put an equal sign down and do 7/8. Okay, so that's subtraction. Let's see how we could model multiplication. If we erase our models here and I take my segments off, I can now model the following problem. I want to model 3/8 times 5. Okay, or 5 times 3/8 we could say. That would mean we need 5 sets of 3/8 if we treat it as repeated multiplication. So let's just draw a model for 3/8. So again, grab one of your segments, and you want to drag that over and make that into 3/8. And now what I want to do is I need 5 of these. So there's a couple ways I could do it. I could clone that, and every time I clone it I have one more set of 3/8. So if I match that up, I'm going to have my 3/8. Now if I wanted to make it a little clearer, what I could do is instead of making that red, I can make that blue, or I could have copied over another line, but let's make that one blue. And now we have a blue one, so it's easier to see. So now I have what? I have 1 3/8, I have 2 3/8. Now what I'm going to do is I'm going to clone this red one, and I'm going to then put that next. So now I have how many sets of 3/8 have I got on my hands? Well, now I have a set of 3 of them. And now what I want to do is I want to clone it again, but this time I'm going to clone a blue one. And I clone that blue one to be another 3/8, so I tack on another 3/8 here. And now I want to tack that one more on, and I'm going to do that in red so it just sees it again. Clone that one and move that over, and again you can see that I have what? 5 sets of 3/8. 1 set, 2 sets, 3 sets, 4 sets, and 5 sets. Once I have that, I can then say what's my answer. Well, my answer is going to be, again, I can draw my segment here to be 1, because the kids will see that it is 1 inch, and the answer is 1. And then I see 1, 2, 3, 4, 5, 6, 7, 8. So my answer is going to be 1 and 7/8. But we'd also take the opportunity to look at all these and count up how many 8s we have. Well, we have 8 8s in 1. So we could write 8 8s down. And in this part right there, if I just use a different color and I draw the segment from here to the end, I can see that that is going to be 7/8. So I can write down my 7/8 here. And I could say that the whole segments together, of course, are 15/8. So then I can extend my explanations as to saying, well, how could I get 15/8 out of this? And then we could go into the traditional algorithm, and we could say, okay, I have 3/8 over 5 times 1, and we could get that answer to be 15/8. Okay, so that gives you an idea how we might do multiplication. Let me just erase these fractions out. We'll just do something real quick with division. Let me take my segments off, and notice how I highlight all of those at once and just delete all of them at once. Okay, so what we want to do is now we want to take a look at how we could do division. So this one, I'm going to ask, how many quarters are there in I don't know, how many quarters how many quarters are there in 1 1/4? So I could write this down as 1 1/4 divided by 1/4. So we're going to ask, how many quarters are there in 1 1/4? So the best way to do that is to draw your dividend 1 3/4 with one of the lines, and that would give you 1 3/4 and 1 1/4. Sorry, and then I can match that up by taking another color and do what we did before. You can mark off your You can mark off your quarter. But the way I'm doing here, I gotta just grab that the right way here, and basically what I want to do is make that into a quarter. So what I can do now, remember the kids, or you're asking the kids to do this along the same way. Again, I could either take that or take another color so they could count how many quarters there were, make it a little clearer, or I could just draw it and count the quarters myself here. So that's 1 quarter, 2 quarters, and I can clone that like we did before, and I can, whoops, I made it a little longer, I don't want to do that. And now I want to just move that over, and I have another quarter, and then I can clone this one, and I have another quarter, and let's move that over, and I can clone it, the red one more time, and I can have my number here being quarter, and I can clone that, move it over, and my model, of course, is 1 2 3 4 5. So 1 quarter, how many quarters are there in 1 1/4? There are 5. Then you could show them, after you do a bunch of problems like this, you could then show them that you could change this to the traditional model of 5 quarters divided by 1 quarter, and we know, of course, that that would be 5 quarters times 4, and of course that does give us 5. Okay, so basically this is an opportunity to get kids to read rulers. It's an opportunity to model solutions to problems, and then go ahead and do the algorithm. The algorithms will mean so much more to students after they model them on the templates. And I can't stress again the importance of getting kids actively engaged. All kinds of questions that you can ask to get the kids to do this, and basically the more that you have the kids use the communicator and hold it up and then model the answers, that's a great way to do it. You could reverse the situation on the kids. You could say, I want you to look at the model, and you could make these up ahead of time, but you could take this and you can take your model and you could really have them show you and write down the problem. This is the problem I want to write down, and I want you to tell me what addition problem this shows you. So really what I'm saying to the kids is, tell me what I'm adding together here. So let me change this, and I want you to tell me the problem, and then I want you to tell me the answer. Whoops. So we can bring these down again a little farther if we want to. We can put them right on there, and basically that would be, of course, a problem where the red one could be read as 1 1/4, and to 1 1/4 I'm going to add 1 2 3 4 5 16ths is the blue one, and then I could say that the answer is 1, and we could count these up as 8 16ths, 9 16ths. So the answer is 1 and 9 16ths. You could also make up multiplication problems. You could do one on each one of these. You could do an addition problem here, a subtraction problem here, multiplication problem here. So basically you have a lot of variety. You can model, or you can assess how well they understand it by having to just write down the problem and the answer as you model it up here. A lot of opportunities for interaction with kids. Okay.